Welcome to the Learning Curve Academy. In this video, I will be looking at normal distribution, which is one of the most popular statistical distributions. I've done previous videos on normal distribution and its applications, so you can check out those in the statistics playlist on the channel. These are some different types of normal distribution problems from that which I looked at before. Moreover, in this video, I'll be using the half table. That is the standard distribution table that is called the half table, which is slightly different from the table that I used previously to teach normal distribution in my videos, which is called the full table. I'll talk more about the half table when I get to actually using it to develop readings. Here we are told that the random variable z has a standard normal distribution. Determine the value of a. So here we're asked to determine the actual value of a, which is going to require that we find out a particular z value. So a is like a z value that we will find out that is associated with a particular probability. So in the first problem, we are told that the probability that z is less than a is equal to 0.9953, and we're asked to find the value of a. So the first thing I'm going to do here is that I'm going to draw the standard normal curve to illustrate the area of interest. Now, in the standard normal curve, the value in the middle of the curve is 0. And we're asked to find the probability that z is less than a value a. So the value a is a positive value that I'm looking for, which is obviously to the right of 0. And the area to the left of that value produces a probability reading of 0.9953, which is what we're told in the question. So the probability that z is less than a is equal to 0.9953, and all we need to do is to find this value here, a, which produces a table reading from the standard normal table of 0.9953. So, to do that, we're going to go to the standard normal table. Let us always remember that when you read a z value from the standard normal table, it always gives you the probability of the area to the left of a value. Always. That's very important to remember. Whether you're using the half table or the full table, the principle is the same. Now, 0.9953 is not a probability that we will be able to find on the half table. The half table only goes up to 50%, or half of the probabilities of the full table. The full table goes up to the total probability of 1, but the half table only accounts for literally a half of the standard normal curve, which is 50%. Because the half table only accounts for 50% of the standard normal table, it means, for example, that when I read the half table, I would only be getting this portion here to the left of 0, which is 50%. And then there's this other portion here, which would account for 50%. Take out 50% taken away from the given probability. That's the area between 0 and a, would be 50% or 0.5 subtracted from the given probability. So, in order to determine this result, I will need to take 0.9953 minus 0.5. The only reason why I need to do this is because I'm working with a half table. So when we subtract here, we're going to get 3, 5, 9, and 4. 5 taken away from 9 here is going to be 4. So what I need to look for, because we're using the half table, we're going to need to look for the z value that corresponds to a probability reading of 0.4953. Once we come up with that value, then that value will be the value of A. If I was working with a full table, I would just go to the full table, search for the probability of 0.9953, and the z-score that corresponds to it would be my solution. This is a simple case because this is the probability that z is less than a value, and any value read from the standard normal table automatically gives you the probability of the area less than a value, or to the left of a value, in other words. So these less than problems are really simple. So let us go to the start. We're looking for 0.4953, so we're going to go to the half table. Here's the half table, so 0.4953. We're going to look for that in the body of the table, or the closest value to it. So 0.4953, the further down and across you go, the larger the values become. So here is 0.4953. And we're going to say, what is the z-table reading that corresponds to it? So we search for a probability of 0.4953. Then look for the z-value that corresponds to it. So I go down in this column, and that's 2.60. And that's the answer. 2.60. So the probability that corresponds to 0.4953 is 2.60. So A is equal to 2.60. That's the value that we're looking for here, 2.60. So A, the probability that Z is less than 2.60 would be equal to 0.9953 from the full table, or 0.4953 from the half table. So the Z value here that I'm looking for is 2.60. And that gives us the probability of 0.49 in the half table, and would have given us the probability of 0.9953 in the full table. So that is how we deal with problems like that. Let's go now to B. We're going to look at quite a few questions here to ensure that you understand these fully. So now we're asked to calculate the value of A, or determine the value of A, given that the probability that Z is greater than A is equal to 0.2743. So I'm going to draw the standard normal curve here. In the center of the standard normal curve is 0. And I'm going to mark the value A, which is a positive value to the right of 0 here. And what we're looking for, remember, all values to the right of 0 are going to be positive. So since A is a positive value, it has to be to the right of 0. We are told that the probability that Z is greater than A, so we shade the area to the right of A because this is Z greater than A. And we are told that that probability is 0.2743. That's what that probability is. So when we think about this now, what we really need to find is a value of A that will produce. So what we really need to find is a Z value that will produce a probability of, we need to find the Z value that will produce a probability of 1 minus, because the total probability is 1 minus 0.2743. So that's the probability that we really need to find here. And 1 minus 0.2743 is going to give us the probability to the left of A. Now remember that when you read from the standard normal table, it will always give you the area to the left of a value. So when I take 1 minus 0.2743, I get 0.7257. That's what we get, 0.7257. So therefore, what we need, 0.7257, is this entire area to the left of A. And since we know that reading from the standard normal table will always give you the area to the left of a value, never to the right, then this becomes simple. Now that I know the probability to the left of A, which is 0.7257, because the total probability of the area will always be 1. So now that I know the probability to the left of A, then in a full table, I will just go straight ahead and search for it and find the z value that corresponds to it, and that's our answer. But in the half table, we will have to go ahead and subtract 0.5 from the 0.7257. So we'll take 0.7257 minus 0.5. And the reason for subtracting 0.5 here again is because the half table only accounts for 50% of the probability. If you are using a full table, we would just conclude the problem right away by just reading for 0.7257 from the table, and that would have been our answer. When we subtract here, we get 7, 5, 2, and 2.2257. That's what we get. Now, 0.2257 would represent our probability between 0 and A here, right here, because the half table would account for that side fully. So what we're going to do now, guys, is that we're going to go to the half table and we're looking for 0.2257. So 0.2257, we're looking for that probability, and here it is, 0.2257, which corresponds to 0.60. So the probability that is associated with the z-value rather that is associated with a probability of 0.2257, we just found from reading the half table to be 0.6. 0.6 would be the z-value. So it means that the value of A, which is the probability that is associated with 0.2257, is equal to 0.60. So that's the value of A. It's 0.60. So A is 0.60. In other words, 0.60 is that value whereby the probability that Z is greater than that value, in other words, the probability that Z is greater than 0.60 would be 0.2743. So that's our answer. This is how we deal with greater than a positive value. If it was just less than, it's much simpler. Less than a positive value, as we saw here. It's greater than a positive value. You have to do a little bit more, first subtracting the given probability from 1 to get the probability of the area to the left, and then taking 0.5 from that probability and searching for the result on the standard normal table to see what the z-score is. So that's the answer. Now, let us do two other problems which are very similar to the ones we just did to reinforce the concepts. Here we're asked to find the value of A, given that the probability that Z is less than A is equal to 0.9192. So the first thing we do is to draw our standard normal curve. Again, for the standard normal curve, 0 is in the center. A is a positive number here, so it has to be to the right of 0. This is just a sketch, so you don't have to worry about scaling. So let's put A here. Okay. And what do we need here? We need the area to the left of A, because that's what we're told, that we're asked to find the probability. We're given the probability that Z is less than a value A, and we're asked to find what that value A is. What is that value A, which will give us a probability of 0.9192 when we read from the standard normal table, because again, I want to remind us that when we read from the standard normal table, it always gives us the probability of the area to the left of a value. Okay? So this is really simple now. We are told that the probability that Z is less than A is 0.9192. 0.9192. So, since we need that area to the left of A, and we know that the half table only accounts for 50%, we're going to take 0.5 from the 0.9192. So this is going to give me 2914. Of course, so it's 0.4192. So what I need now is the Z reading. I need the Z table reading that corresponds to this probability of 0.4192. So Z, and that will give us the result for A. So we need to find 0.4192 in the body of the standard normal table and determine the Z value that corresponds to it. So 0.4192, that's what we're looking for, 0.4192. So we search through the table here. Here it is, 0.4192, and that is 1.40. 1.40. So our answer is 1.40. That's the value of A that we're looking for here. In other words, the probability that Z is less than 1.4 is equal to 0.9192. That is the value of A, 1.4, whereby the area to the left of it, in other words, the area less than it, would give us a probability of 0.9192 on the full table, or on the half table 0.4192, having taken 0.5 from it. So that's how we really reason through these problems logically and easily. Let's go to this other one. This one is a greater than problem. We're asked to find the value of A such that the probability that Z is greater than A will be 0.8849. So again, A here is positive, so I just locate an area roughly arbitrarily to the right of 0. I'm going to go upwards. I'm going to shade the area to the right, because that's what we are told here, that the probability that Z is greater than A is 0.8849. But if we think about this, so 0.8849, if we think about this logically, the fact of the matter is that if the area is 0.8849, then the value of A is actually going to be on this side, because the total area on this side is only 50%. So we're going to modify this a little bit. And because we have recognized here that the total value of A, the total area to the right of A, so although A here is specified as a positive number, when we look at the probability that we have here, the probability of 0.8849, it's actually bigger than 0.5. And since we know that half of the curve, which is the area to the right of 0, only accounts for 0.5, from here, 0, straight to the end is only 50%, or 0.5. So because this value here is bigger than 0.5, we know that A is actually going to be negative in this case. So let's just fix that up. So A is going to be a negative value, and the area to the right of it would be this entire area, which has a probability of 0.8849. Now, again, I want to underscore the reason why we were able to recognize that A could not be on the right side in this case. A could not be on the right side, even though the value of A here is indicated as a positive. It could not be on the right side because it would not be possible for the probability to the right of a value, the probability to the right of any value to the right of A, to the right of 0, the probability of any value to the right of 0 could not be 0.8849, because from 0 to the end of the curve rightwards only accounts for 50%. So that would not be possible for us to get a z value whereby the area to the right of it is as large as 0.8849. So because of our recognition of that, then we know that A is going to be a negative value, because 0.8849 is larger than 50% or 0.5, and we're finding the probability that Z is greater than A. Then we know A has to be negative because we need a bigger area than 0.5, which would only be from 0 to the tail. So that's why we recognize that we have to shade an area to the left of a negative value, primarily to the right rather. That's how we recognize that we have to shade the area to the right of a negative value. And that is because the value in question, the probability value in question, is greater than 0.5. If it was a value less than 0.5, then how we started the problem here, how I started to illustrate the problem would have been correct, in the sense that we would have gone to the right of 0 and just shade an arbitrary area to the right of that value. But having recognized that the value of the probability is bigger than 0.5, and we're trying to find the probability of the area to the right of that value, then it wouldn't be possible for A to be a positive value because we need a larger area than 0.5. So that's the rationale for this adjustment. Now we're going to have to use the symmetric properties of the curve to solve this problem. Now the area to the right of any negative value is the same as, so the area to the right of any negative value is the same as the area to the left of the corresponding positive value. In other words, the area to the right of negative A would be the same as the area to the left of positive A. And this is because the curve is symmetric. So the area on both the left and right are equal. Okay? In other words, in the same way that the area to the right of negative A produces 0.8849, it is the same way that the area to the left of positive A would also give us a probability of 0.8849. So again, the area to the right of a negative value is the same as the area to the left of the positive value that corresponds to that. So for example, if this A was, let's say, negative 2, the area to the right of negative 2 would be the same as the area to the left of positive 2. And this is a fact because the curve is a symmetric curve. When you're working with a negative value and you're only given the positive side of the half table, as is very common and as is the case in our worked examples here, we have to flip the curve. So flip the curve. Once you get a negative value, just flip it to the other side of the curve. And take the corresponding area to the left of a negative value in a case like, left of a positive value in a case like this. So the probability of the area to the left, rather to the right, the probability of the area to the right of negative A here is the same as the area to the left of positive A. Just like the area to the right of negative 2 would be the same as the area to the left of positive 2. The area to the right of negative 3 will be the same as the area to the left of positive 3. It's as simple as that. And we have previously looked at how to find areas to the left of a positive value using the half table. So what we're going to do now is that we're going to go straight ahead and take 0.8849, which we would not be able to find on the half table. So we're going to subtract 0.5 from it, which is going to give us 948 and 3. This is 0.3849. And what we're going to do is that we're going to search for the z-score from the half table that corresponds to 0.3849. So we go down to the half table and we're looking for 0.3849, which is right here. So the probability is 1.20. 1.20. 1.20. That's our answer. So A would be 1.20. Therefore, since we recognize that the original value of A would be a negative, then our answer is actually going to be negative 1.20. Positive 1.20 would be the value right here when we flip the curve, but we still have to find out what that negative value is, whereby the area to the right would give us a probability of 0.8849. So we know that the value of A, the answer is that the value of A is negative 1.20. Okay? And that's how we deal with these situations. Now let's look at a slightly more interesting situation. Here we're asked for the probability that Z, find the value of A, whereby the probability that Z is greater than A but less than 1.6 is equal to 0.7865. So let us draw the curve to illustrate this area. Draw the standard normal curve. In the center of the standard normal curve is 0. And where we need to find the value between here, A and 1.6. The trick here is to recognize that the probability is bigger than 0.5. So because the probability here is larger than 0.5 and we are working with a half table, then this interval has to be spread between a negative value and a positive value. It would not be possible for both values to be on the right side of 0 or on the left side of 0. It has to be a case that A is negative, which is to the left of 0. So we're interested in this entire area from A to 1.6, which is bigger than 0.5. So once the area in an interval problem like this, once the area is larger than 0.5, then you're going to have one of the values in the interval being negative, in this case A, because it's to the left, and one being positive. So A, ultimately when we find the value of A, it's going to be a negative number. Now, the area here will give us a probability of 0.7865. Now, when we're working from the half table to find the probability that an interval involving a negative value and a positive value, when we're working from the half table to find the probability associated with an interval that contains a negative value and a positive value, the easy way to do it is to take the z-table reading for the positive value and add the z-table reading that is associated with the positive of that negative value. In other words, when I take the z-table reading from the half table for 1.6 and the z-table reading for A, the positive number associated with A here, it should give me the probability that we're given here of 0.7865. So we can go straight to the half table now and read for 1.6. When I read 1.6, it gives me 0.4452. Okay, 0.4452. So 0.4452 plus z of a, I'm just going to write it back as is, plus z of a should give us, now z of a is the probability reading for a from the standard normal table, should give us 0.765. So I'm going to do a little bit of transposition here. If I make z of a the subject here, this is going to give me 0.7865 take away 0.4452. 4452. So z of a is going to give us, so we need to now just subtract 0.4452 from 0.7865. 0.7865 take away 0.4452, and that gives us 0.3413. So all we need to find now to get A is to look for 0.3413 in the standard normal table. So we're going to say, therefore, A would be equal to, so we're going to just look for the value in the standard normal table that corresponds to 0.3413. So we go down here, and we're looking for 0.3413, which is here, which is 1.0. Okay, so the value of A is 1, but because A is on the negative side of 0, we use negative 1.0. So that's the value of A. A is equal to negative 1.0. And this is how we handle these kinds of situations. Again, be mindful. Whenever the probability that you're given is greater than 0.5 and you're working with an interval, then it has to be the case that one of those values is negative. In this case, the lower limit has to be negative, right? And the easy way to solve using the half table, the easy way to derive probabilities from the half table where one value is negative and one value is positive is to simply take the table readings for each of them, for each of the values in the interval, and add them. But because we do not know what A is in this case, I set this out algebraically and transpose to get the probability that is associated with A, which is 0.3413 by transposition, and then we just search for 0.3413 from the standard normal curve, yes, and the z value that is associated with 0.3413 is 1, but since we know A is negative, the answer is obviously going to be negative 1.0, and that's the answer. So we've looked at a number of possible situations here in which these normal distribution problems could come, where your interest is in finding the value of a z value, which we call A in these problems. You're really finding a z value which produces a particular probability in a problem situation. So I hope you found this video to be very useful. I will be doing many more future videos in statistics, including a normal distribution. Stay tuned to the Learning Curve, where we learn all things math. Remember to like, share with your friends and your colleagues studying mathematics and statistics, and others in the field who are interested in building their thought processes. Thank you, everyone. See you soon. Like, share, and subscribe.